Assalamu alaikum student. Bismillahirrahmanirrahim. I hope so boys you will be very much well, and today we are just going to uh, recontinue the previous chapter, propagation and refraction of light. And now today we are just going to discuss about the numerical, which is just related with the previous lecture. Main. In the previous class, first we have discussed about the types of the mirrors. So there are two types of the mirror. The first one is the plane mirror and the second one is the spherical mirror. And now another, there are two subtypes of the spherical mirror. Mean the first one is said to be the concave mirror and the second one is the convex mirror. In concave mirror, we have discussed about that it is a converging mirror and it is giving us real and inverted image. So, in previous class, I was told you that the object distance of the concave mirror will be positive and represented by the small p, while the image distance is represented by the small q, and for the concave mirror we will get in positive. Now the next one is the focal length. Focal length, we can say the distance between the focus and the pole or vertex is said to be the focal length. Now for the concave mirror, the focal length will be positive. Now, next one is the convex mirror. For the convex mirror, object distance similarly represented by the small p and its value always will be in positive, while their image distance will be in negative. Why? Because it is giving us a diverging image, and that will be, we can say, virtual and erected. If the image is virtual, so Q will be in negative. If the image is virtual, keep in your mind, if the image is virtual, then it will be always negative, while its focal length will also be in negative. Again, I'm repeating this sentence. For the focal length of the convex mirror will be in negative. After that, we have discussed about the mirror formula. So in mirror formula, we have learned that 1 over f is equal to 1 over p plus 1 over q. After, at the end, we discuss about the magnification and we learn magnification is represented by the capital M, and it is equal to the ratio of the image distance and the object distance. So it is represented by the q upon p. Also it is equal to size of the image like hi and size of the object like h2. Now student, we are just going to solve the numerical. So you just have to be memorize all of these formulae. So first of all, we are going to solve the numerical 13.1. In 13.1, it is saying that an object is placed at a distance of 30 centimeter from a concave mirror of focal length 5 centimeter. If the object is 5 centimeter high, find the position and size of the image. The main thing of the numerical is that first learn. We have to learn numerical in multiple times so that we can get what is the given, what is the required, and which formula we will apply on this numerical. So after that, here we have learned that an object is placed at a distance of 30 centimeter from a concave mirror of focal length 5 centimeter. If the object is 5 centimeter high, then we have to find position and size of the image. So in the data, first of all, we will write about the given. In the given, first of all, object is placed. Object is placed means object distance is 30 centimeter. Object distance is 30 centimeter and it is represented by the small p. So small p is equal to 30 centimeter. After that, focal length. Focal length is represented by the small f and its value is 5 centimeter. Now here, if the object is 5 centimeter high, so this is said to be the size of the object, and size of the object is represented by the HO. I hope you will understand what is a given. Now we are writing required. In required, two things is main object. The first one, we have to find the position of image, mean image distance, and represented by the small q. After that, we will find out size of the image, and size of the image is represented by the hi. Now here, after that, we are going to solve it. So here we can say that we are using here mirror formula to find out the position of image, mean q. For using the mirror formula and to find out the object, we need two quantities, because in the mirror formula three quantities are present. If we have the two, then we can find out the other one. So here we learn that f is given, p is given, so we are able to find out 1 over q. So first of all, we will shift 1 over p on the other side to find out the value of 1 over q. That's why we are making it as a object. Let's see. If we will shift 1 over p on the other side, so it will come into the negative, because here 1 over p is in positive. When we will shift it, then it will come in negative. So we can write 1 over f minus 1 over p is equal to 1 over q. After that, we can also written as 1 over q is equal to 1 over f minus 1 over p. Now after that, we are substituting their value. So 1 over q will remain same, while 1 over f will become 1 over 5 minus 1 over p is 30 centimeter. After that, we will find out their LCM. To solve the fraction, we just have to find out their LCM. So the LCM of 30 and 5 will become 30. And now here, first we will go to find out the value of first fraction. So first of all, we will compare their denominator. If the denominator is a match with the LCM, then we will write their numerator as it is. And if they are not matched with the LCM, then we will try to equalize it. Now let's see 5 here is 5 and here is 30. So 5 is not matching with 30. So we will think over that by which number we have to multiply 5 to get the 30. We know very well. If we multiply 5 with 6, then we get the 30. But according to the mathematics, if we are doing the operation at the denominator, so that will be for the numerator. Mean if we are multiplying 6 with 5, then we have to must multiply with 1. So 1 6 ones are 6, and 30 6 5 the 30 will match with this 30. Now we are going on the next fraction. On the next fraction, the denominator is 30 and here LCM is 30. So they are matching. So we just write their numerator as it is. After that, we will simplify it. So here we will write 1 over q as it is equal to 6 minus 1 mean 5, and 30 will remain same. After that, we will must simplify it. So 5 ones are 5, 5 6 are 30. We will cancel it. 5 ones are 5, 5 6 are 30. So here we are getting 1 over q is equal to 1 over 6. After that, we will just going to cross multiply. Mean q will multiply, cross means this q will multiply this 1. Mean denominator of the first fraction, or we can say left fraction, will multiply with the numerator of the right fraction, while the numerator of the left fraction will be multiplied to the denominator of the right fraction. So it will become q ones are q and 6 ones are 6. So here we are getting q is equal to 6 centimeter. I think so student, you will understand after that. The next one is to find the size of the image. We use magnification formula. So magnification formula we will learn m is equal to hi over ho is equal to q upon p. Here our main object is hi over ho, that is equal to q upon p. Why? Because here m is not given. We just having the value of hi. We have to find the value of hi. We have ho, q, which is still find out its value, and p is already given. Now, so here we can say hi will remain same. At the place of ho, we will compute 5 and q is 6 while p is 30. After that, we will shift 5 on the other side because here 5 is in denominator. So we can say hi will be equal to 6 multiplied by 5 divided by 30, or also we can say that 6 upon 30 will multiply with 5. So let's see, this 6 will multiply by 5. 6 5s are 30. Then this 30 will cancel this 30 and we just get 1. So unit will be centimeter. So the size of the image will be 1 centimeter. Size of the image will be the 1 centimeter. Okay, sir, did you get it? Now we are going to solve the next numerical. Second numerical is 13.2. In 13.2, it is saying that if an object is placed at a distance of 10 centimeter from a spherical mirror, if an object is placed at a distance of 10 centimeter from a spherical mirror and its virtual image is formed at a distance of 5 centimeter from the mirror, find the focal length and nature of the mirror. So what are they given in this numerical? The first one is the object distance. And I was told you in the previous numerical, uh, object distance is represented by the small p. So here, object distance is represented by the small p is equal to how much? That is a 10 centimeter. After that, from a spherical mirror and its virtual image is formed at a distance of 5 centimeter. Mean here image distance is given and image distance is represented by the small q. Image distance is represented by the small q. Its value is 5. But why we are writing here minus? Because I was told you that if the image is virtual, then image distance will come in negative. So let's see here. According to my pointer, visual image is formed. Visual image is formed. So this value means 5 centimeter will come in negative. Mean this negative is also showing the direction of the image. Now the next one required. What is the required? The first required is focal length. Number one, focal length. And the second is nature of the mirror. Nature of mirror. So here we will also use mirror formula, and you know very well about the mirror formula, that is equal to 1 over f is equal to 1 over p plus 1 over q. Now here object distance mean p is given, image distance q is given. So we are going to compute their value. So it will become 1 over f will remain same, while 1 over p will become 1 upon 10 plus, as it is, 1 upon q will become 1 upon minus 5. Why I am writing minus 5? Because here the value of q is minus 5. Now, before going to simplify it, first we will multiply their sign. Now here sign is minus and here sign is plus. So plus minus plus multiplied by minus is equal to minus. In plus minus minus. So we get 1 over f is equal to 1 over 10 minus 1 over 5. I think you will understand about the data required given as their formula. Now we are going to simplify it. So here first of all we will take the LCM of the previous fraction. So we got the LCM is 10. Let's see, 10 and 5. We have to take the LCM of 10 and 5. So the LCM will become 10. Now after that we will check out their fraction. In the first fraction the denominator is 10, while in LCM denominator is 10. So they are matching. So we will just write down their numerator as it is. Now after that their numerator is 1. Now we are going to switch over the next fraction. Next fraction is 1 upon 5. So here their denominator is not matching with the LCM. So what will be happen? We will check it by which table we have to multiply with 5 to get the 10. So 5 will multiply with 2, then we will get the 10. So 2 as it is multiplied with the numerator. So 2 ones are 2 will become 2. So on the next step, we will just simplify it. 2 minus 1 plus minus minus. We have to subtract it. 2 minus 1 mean 1. But this 2 having the greater number, and sign is negative. So in the answer we will write the negative. After that, to get the value of f, we will just cross multiply it. Mean this 10 will multiply by 1. So 10 ones are 10. And this f will multiply by minus 1. So it will get the minus f, or you can also written as minus f. Now let's see. If the uh, focal length if the focal length is in negative, so the nature of the mirror will be convex. If the focal length is in negative, so the nature of mirror will be in convex. So here, like that. Negative sign of focal length show the nature of mirror is convex. Okay, student. Now we are going to discuss the next numerical 13.6. So 13.6 is saying that the radius of curvature of a concave mirror is 40. The radius of curvature of a concave mirror is 40 centimeter. Where should an object be placed as to get real image? Magnified 4 times, magnified 4 times. Again, I am repeating to understand the question. The radius of curvature of a concave mirror is 40 centimeter. Where should an object be placed so as to get real image magnified 4 times? Mean, what do you think about the radius of curvature? Radius of curvature we can say that is the double of focal length. Radius of curvature mean that is a double of focal length. Mean if we will take the twice of the focal length, then we will get the uh, radius of curvature. Or in other words, we can say focal length is the half of the radius of curvature. Focal length is the half of the radius of curvature. Now, in given, we having first radius of curvature, and the radius of curvature is represented by the small r. Radius of curvature is represented by the small r, that is equal to 40 centimeter. Now the next one is the magnification. Magnification is represented by the capital M. Magnification is represented by the capital M, and it is giving us 4 times. So M is equal to 4 times. Now here required is position of object. Position of object mean we have to determine the object distance. We have to determine the object distance. Mean we will find P. So first of all, we are going to determine the two things. The first one is the focal length, and the second one is the image distance. Now, first of all, we know that the focal length is half of center of curvature. F is the half of the center of curvature, or we can say radius of curvature. So F is equal to R upon 2. F is equal to R upon 2. So F is equal to R is how much? 40, and 2 will remain same. So we are just simplified. So 2 ones are 2, 2 20s are 40. 2 ones are 2, 2 20s are 40. So here we get the F is equal to 20 centimeter. After that, we will go to find out the image distance, mean Q. So we will use here as a magnification formula. So in the previous we discussed about M is equal to HI over HO, also equal to Q upon P. So here we will just manipulate it like m is equal to q upon p. M is equal to q upon p. So here magnification is 4 is equal to q upon p. So to find the value of q, we will shift p on the other side. To find the value of q, we will shift p on the other side. So it will become 4 times of the object distance will equal to image distance. Mean magnification here showing that the 4 time of the object distance is equal to the image distance. Now, the main objective is that to find the object distance. So what will be the object distance? So here to find out the object distance, we will use a mirror formula. And mirror formula we have 1 over f is equal to 1 over p plus 1 over q. 1 over f is equal to 1 over p plus 1 over q. This is the mirror formula and we are using it to find out the object distance mean p. This is the mirror formula which we will use to find out the p. So here we get the focal length is 20 and object distance will remain same like p, while at the place of image distance we will compute for p, because here look at here q is equal to 4p. So that's why we will write at the place of q 4p. Now boys, uh, we are going to find out the p. So first we will take the LCM of p and 4p. Why we are not going to shift this on the other side? Because 1 over p and 1 over 4p is not matching with 1 over 20, or we can say these are not the like term of this term. So that's why we are just going to solve it here now. So we are taking the LCM of p and 4p. So their LCM will become 4p. After that we will match the denominator of the first fraction. Here denominator is p while their LCM is 4p. So what is the difference? Difference is that here 4 is not given or 4 is not present. So we just have to be uh, similarize it. So we will multiply 4 with denominator as well as with the numerator. So at the top it will become 4 1 the 4, and at the bottom or in the denominator it will become the 4p. So this 4p and this 4p will match and we will write this 4 as it is. After that we will going to solve the next fraction, and next denominator of the next fraction is 4p. This 4p and this 4p are similar, so we will write their numerator as it is. Here 1 is given. After that we will add 4 and 1. So 4 plus 1 is equal to 5. So we are getting 1 over 20 is equal to 5 upon 4 pi. Here, to get the value of p, what will be happen and what we have to do? We will just cross multiply it. Mean this 4p will multiply with 1, then 4 ones are 4p, 4p ones are 4p, as well as this 20 will multiply with 5. So it will become 520 the 100. So here still now p is not in the isolated form. So we just have to make it isolate. So we will remove 4 from here. So what we have to do? We will just shift on the other side here. 4 is in multiplication with p, so after shifting it will come in division. So we can also say that p is equal to 100 upon 4. So 100 will divide by 4, then we got the p is equal to uh, 25 centimeter. So we can say that the object distance is 25 centimeter. I think so, student, you will understand. Now we are just going to solve the next numerical. And the next numerical having mm, uh, the something as a different, or we can say sometime it is just going to match the other numerical. So, but in exam, when we are solving the numerical, so we have to identify, okay, either it is just going to relate the other one or not. Sometimes the numerical value is just also a change. So here in 13.7 it is saying that an object is situated at a distance of 20 centimeter from a convex mirror of radius of curvature 20 centimeter. Find the position and nature of image. Now I'm just going to repeat it. An object is situated at a distance of 20 centimeter from a convex mirror of radius of curvature 20 centimeter. Find the position and nature of image. Now let's see. This numerical is just matching with the previous, like a 13.6, because here radius of curvature is given, and in the previous one radius of curvature is also given. So here an object is situated at a distance of 20 centimeter, mean object distance is given here now. ठीक है? But on that situation, object distance we have to be find, and where we have to find out the object distance. Also, image distance is not given. So, uh, first we have to find the uh, on that situation Q and focal length. Then we are going to solve the object distance. So here it is very simple. Object distance is given, and by the radius of curvature we will also find out the focal length, right? And only one thing here we have to find, that is the position of image as well as nature of image. Now first of all, make up the data, like object distance, uh, p, object distance, represented by the small p, then p is equal to how much? 20 centimeter. P is equal to 20 centimeter, and from a convex mirror of radius of curvature 20 centimeter. So here r, what I was told you, r means radius of curvature, not only the radius. Here r means radius of curvature, that is equal to 20 centimeter. After that, what is the required? First required is position of image, and the second one is the nature of image. First, what we have to find? Position of image, and second is nature of image. And from where we get the nature of image? We will get the nature of image by finding the image distance, right? If the image is in positive, then we can say it is a, if the image distance is in positive, then we can say it is a real image. And if the image is in negative, then it is said to be the virtual image. So here, which formula we will use? So before going to find out the position of image, or we can say that is a small q, first we have to find out the focal length, and focal length can be found out by the help of the half of the radius of curvature. So let's see, as we know that as we know that the focal length is half of center of curvature, or half of the radius of curvature. As we know that the focal length is half of radius of curvature. So here we can say that f is equal to minus r upon 2. F is equal to minus r upon 2. Why minus is showing here? Because we can say that uh, negative sign arises due to convex mirror. Why we are using minus? I was told you, okay, for the convex mirror, focal length will come in negative, and the previous one, in the previous numerical, I was told you, okay, why we are saying it is a convex mirror. Because we are getting the f is in negative, right? So here, that's why I'm showing here uh, f is equal to negative r upon 2, mean negative sign arises due to convex mirror. Here mirror is convex, so their focal length either it is showing or either it is telling you it is negative or not. So just keep in your mind, if the mirror is convex, then the focal length will be negative. If the mirror is concave, then the focal length will be positive. That's why I'm just writing it down. F is equal to minus r upon 2. After that, we are going to computing their value. Mean r is 20 and 2 will remain same. So divide 20 with 2. Divide 20 with 2, then we get the 10 centimeter, because 2 tens are 20. So F will be negative 10 centimeter. Now we are going to find out the position of image, or we can say image distance, that is represented by the small q. So here we will also use the mirror formula. And what is the mirror formula? It is given us or written in front of you. That we can say that is a 1 over f is equal to 1 over p plus 1 over q. 1 over f is equal to 1 over p plus 1 over q. After that, we will make the subject. Which one? For the image distance. And image distance is represented by the q. So 1 over q will make as a subject by shifting 1 over p on the other side. Here 1 over p is in positive, after shifting it will come in negative. So we can write it 1 over f minus 1 over p is equal to 1 over q. 1 over f minus 1 over p is equal to 1 over q. So it can also be written as 1 over q is equal to 1 over f minus 1 over p. Now, after that, we will computing their value. Mean 1 over q will remain same. 1 over q will remain same is equal to, at the place of f, we will write minus 10. At the place of f, we will write minus 10. Also, this minus sign will remain same, and 1 over p means that is a 1 over 20. Okay, now why we are writing uh, this f is negative? Because in the previous one we got the value of f is in negative. After that, we will take the LCM of 10 and 20. We will take the LCM of 10 and 20, then we got the 20. Then we will manage or comparing the denominator of the first fraction with the LCM. So here denominator is 10 and LCM is 20. So by which number we have to multiply with the 10 to get 20. So that number is 2. So this 2 will multiply with the 10 as well as with the numerator. So 10 to the 20 will remain same, and 2 ones are 2, we will write here now. So it will come in negative. After that, we are going to solve the next fraction. The next fraction, the denominator is 20, and which is matching with the LCM. So we will write numerator as it is, that is the 1. After that, we will add it. Why? Because both sign are same. When here is negative 2, here is also negative 1. So negative 1 minus multiply by minus plus means here we will take the operation is in addition, but we will write their minus sign because both number having the negative sign. That's why we get the minus 3 upon 20. Now here we have to find the value of q, not to be the 1 over q. So to find the value of q, we will take the reciprocal of the 1 over q. So the reciprocal of the 1 over q will become q only. If we will take the reciprocal here now, so we will must take the reciprocal on here. So it is minus 3 upon 20. So after taking the reciprocal, so it will become 20 upon 3. So here we will divide 20 with it 3. Here we will divide 20 with it 3. Then we got it minus 6.66 centimeter. When we will divide 20 with 3, then we will get minus 6.66 centimeter. Now another require is that to find the nature of image. So let's see. Here Q is in negative. Here Q is in negative. So what will be happen? Then we can say the image will be virtual. The image will be virtual. So negative signs show that image is virtual. I hope, student, you will understand this numerical too. Uh, Alhamdulillah, we have completed this chapter with respect to the numerical. Thank you so much, student, for your cooperation or for your concentration. Now here you're having the home task that is solve all numericals in register. Solve all numerical in register or copy. So all numerical means I have left or given you 3 numerical as in your homework 2. Remaining I was solve it. So just try to solve and get the answer. Okay boys, thank you so much. Allah Hafiz.